Alright, so now let's talk about a geometric sequence. Now a geometric sequence is a sequence with a constant ratio. Unlike the arithmetic sequence, which has a constant difference, the geometric has a constant ratio, which means we are not adding to the previous term, but we are multiplying to the previous term. For example, let's look at this sequence. We have 2, we have 4, we have 8, we have 16. As you can see from this sequence, we are multiplying 2 to 2 to get 4, and multiplying 2 to 4 to get 8, and multiplying 2 to 8 to get 16. So as you can see from this sequence, if I divide 4 by 2, I'm getting 2. And if I divide 8 by 4, I'm getting 2. And if I divide 16 by 8, I'm getting 2. Which means 2 is a constant ratio for this pattern. We call the constant ratio R. So R is equal to 2. Now there is a general formula that we can use to calculate the terms of a geometric sequence. So that's Tn equals to A R to the power n minus 1, where A is the first term and R is the common ratio. So for this previous sequence that we were doing, where A is the first term and R is the common ratio. So for this previous sequence, we can therefore write the general term as Tn equals to our A was 2 with the common ratio of 2 to the power n minus 1. Okay. We can simplify terms by noting that these are two bases which are the same, and we are multiplying this as an exponent 1. So we can add the exponent. So this is 2 to the power n. So Tn is equal to 2 to the power n. So this is the general term of that sequence. So we can use the general term to find other sequences. We know that we can find T14 and T17 and any just term in this sequence. So definitely we can use our calculator and say this is 2 to the power 14 and get 16,384, and we can also substitute any values from this and get any term that we want using the general term. Okay, we might also want to find the term number when given a certain value of a sequence. For example, for this question we are going to ask, what is the term number which is corresponding to 256? We want the term number which is corresponding to 256, which means that 256 is going to be our Tn, and we are trying to solve for n. We are going to use our general term for this question and say Tn is equal to 2 to the power n as a general term, and substituting 256 here, 2 to the power n, we can therefore solve for n. We can factorize 256. You can use your calculator and say 256 equal to shift factorize, that's going to be 2 to the power 8. So we are going to say this is 2 to the power 8 equal to 2 to the power n. Therefore n is equal to 8, because we are going to be dropping the same basis and leaving the exponents. So okay, let's do another question. For this question we have 3 over 2, 3 over 4, 3 over 8, and so on. Again, we can easily note that this is a geometric sequence with a constant ratio. How can we see that? We can divide the second term with the first term, we are going to get half. Divide the third term with the second, they're still going to get half. Divided with the fourth with the third, and still we're going to get half. So for this sequence, you can see that R is equal to half. So we have half as our constant ratio. Again, let's just find the general term. The general term will be, you can also try to find the general term and choose the right answer. So the general term is going to be A is going to be A times R to the power n minus 1. That's the formula. And then we can substitute A, which is 3, times substitute R, which is half, to the power n minus 1. So this is our general term. Right? It's easy as that. Something which is easy. Once you know the first term and your constant ratio, you can therefore use that to calculate the general term. Again, we can ask ourselves, which term number corresponds to a value of 3 over 128? Which term number? So that's going to be our Tn. Tn is going to be 3 over 128. And using our formula, we can therefore find n, knowing that Tn is equal to 3 over 128. So when we're asking the term number, we are looking for n because we are asking which term corresponds to 3 over 128. So we are asking n, the term number, given a term value. So let's substitute that. That's 3 over 128 equals to 3 times 1 over 2 to the power n minus 1. And therefore we can cancel 3 and 3. And we are going to have 1 over 28 equals to 1 over 2 n minus 1. Again, we can factorize 128 and we are going to get 2 to the power 7. So this is 1 over 2 to the power 7 equals to half to the power n minus 1. We can use logarithms, but there's no need since we can easily factorize this. So you can write this as 2 to the power 7. Okay, take 7 out and write like this, n minus 1. Why are we doing? We are trying to make the bases to be the same so that you can drop the exponent. So 7 equals to n minus 1. Therefore n is equal to 8 again in this case. So we have n equals to 8.